Finally, we begin the journey, and today we are at Geocon Labs. We are going to study more about geotech works and how to make a good design mix. I'm Felista, and this is Women in Construction.
Geocon Kanban was established in the year 2009. Geocon measures mainly on geotechnical works and concrete quality control on site. Geocon has a team of engineers, technicians. Geocon has undertaken the following project: Ngong Wind Farm, Lake Turkana Wind Farm, Kipeto Wind Farm, quality control on Tatu City for HLP warehousing, quality control of concrete for robust concrete, and currently we are working on the Konza Technopolis quality control.
Hello, my name is Arnold Kipngeno. Today I'll be talking to you about geotechnical investigations and what it entails to have a geotechnical engineering expert do some investigations for you. So maybe I first start with introducing what geotechnical investigations entails. Say you want to build a bridge, you want to build a house, you want to build a dam. Doesn't matter, just think of anything you're trying to put on top of a soil or below it. You need to understand how the soil will react to what you're going to put on top of it. So how we come in, we assist you to know the properties of that soil and then advise you on the best means for countering what the soil needs to support you. Yeah, so in a nutshell, that's what geotechnical engineering and geotechnical investigations are. You just want to understand what the soil requires, how the soil will react, how the soil will assist you. See, so there are various ways you can do geotechnical investigation. I'd like to put them in three stages. The first stage is the planning part. You study about the area. You want to know the history of the area. You want to know, have there been floods in that area? What was the formation processes in that area? And then the second stage is the field works. You want now to come to the site and take now samples and take measurements on the site, on the soil, on the rock, on where you want to do your developments. And the third stage of geotechnical investigations is laboratory analysis, or the analysis part. Now you take the findings that you have from your first stage and second stage, and now you extrapolate them into your needs, your specific needs. Are you doing a structure? Are you doing a dam? Are you doing a bridge? Are you doing a road? Such like things. So mainly today I'll be talking about the second stage, what goes on in the field, how you can now get the data for you to start analyzing and being specific to your project needs. So there are various ways you can do this. I'll split them into two: an invasive way and the not so invasive way. The not so invasive ways involve things like geophysical studies. You can do radar, you can do electrical ground resistivities, you can do surface wave analysis. So apart from that, I'll be talking about the more invasive ways because they give you the actual conditions that exist, as opposed to the less invasive ways, which are more of an indication. They give an indication of what you can expect. So you can there are many ways you can do this, invasive ways. You can do test pits where you come in and excavate the soil that you on a place that you want to develop. Now the limitations of doing test pits is it limits you to only soft formations like soils and soft rocks. So beyond that, you will not be able to obtain much information. So other ways you can do this is by drilling. That's what I'm going to be emphasizing more on today. And behind me I have a drilling rig that I'll be showcasing today. And when you have a drilling rig, there are many ways you can use it to get samples, because at the end of the day you want to understand what is going on in the ground. So the best way to do this is obtain samples and then take those samples to the lab for testing, and then present the findings to a qualified person who will then give you the right recommendations for your foundations or what you need to adopt. So if you are doing drilling, depending on what you are encountering on site, you can do what we call augering, where you use an auger bit, which is what I have here. So the auger bits will help you to obtain disturbed samples. They are not because of the mechanical action of the auger, you obtain samples that have been broken down. There is a high degree of washing out. So from that you get samples which are more like this. There are samples which have been disturbed. We call them disturbed samples. Yeah. So this is usually necessary for sections that contain soft strata, because the overburden, you usually don't require much of it. So how you recover it is up to your discretion. Now for when you reach the regions that you are more interested in, for low-rise buildings, usually around 1 meter, 1.5, you need now to become more aggressive in your sample recovery. And so what we employ then is a tool like this. Is a cutting tool. This is a drilling bit. You have another barrel that is tied onto this. It's screwed on, and then it's fixed onto the drilling rig. Now what this does, because it's installed vertically, while you're drilling, the soil sample will come as a core, and you will have it contained inside the barrel. Now the barrel is long, usually between 1 meter to 2 meters, so you can make drives. You drive the barrel rotary and vertically using a hydraulic force. So this is driven vertically down in the ground, and there's also a rotary motion. That's why we call the technique rotary drilling or boring. So what this does is it confines a small sample into this confinement, and as you go down, what you continue recovering as you go, as the bit is pushed into the ground and it's drilled. Now from that you have a sample that is almost the same. There is a very little you can do to minimize disturbance. Yes, there is some degree of disturbance, but at the end of the day you get the sample as is in the ground. Yeah. So this is coring. So while you are using this, you usually have drilling fluids to help you in just cooling the bit and sample recovery. When there is a lot of friction in this, the sample will crumble here. But if you have enough lubrication, you will have well maintained samples. Maybe during the field investigations, you can also do some on-site tests. There are very many tests you can do on site to test the soil as is, where it is, as opposed to, now we've recovered the soil, you now go to the lab, you'll subject it to controlled conditions. Now some engineers will want to know how is the ground on its own, where it is. So you do what we call on-site tests. There are many tests you can do. You can have cone penetration tests. You can have standard penetration test. You can have field permeability test. You can also do vein shear tests on the site. And what all these entails is just understanding the ground where it is, as opposed to what is more common as bringing in the samples, testing in the laboratory. You can also do both and have a comparison. What is my controlled testing telling me and what is my field testing telling me? So you compare those two, and then based on what you are requiring, you can then say, if I give a certain confining pressure, I get this. If on its own on the ground with no confining pressure, we get this. So from that, based on your loading parameters, you can now come and say, I need to do this and this so that I cannot exceed the resistance of the soil. So maybe I explain on one test that is done on site, a common one. It's called the standard penetration test, where you have a mass, a hammer, you call it hammer, hammer which is around 63 kilos, and you drive it by a blow motion. So you raise it up and you release it through a free fall height of 760 millimeters on a sampling rod. Now what that does is it pushes the hollow sampler into a soil to a depth of required depth is 450 mm. Now you can count the number of drops that have gone for you to achieve a penetration of 300 millimeters, the last 300 millimeters that you have achieved. Then you can now use that, we call that an N value. It is the number of blows that you have used to achieve a last 300 millimeter penetration in the standard penetration test. So what that does is it gives you an indication of the degree of compactness of the site. Say if generally the harder the ground is, the more blows you'll need to push that sampler into the ground. But the softer it is, you'll need less blows. So it gives you an indication of how hard the ground is and how soft it is, which is also an indication of the bearing properties of that ground. So next, maybe I'd like to show you a core sample of what is recovered. I'll pick just this is consolidated sand. It looks like what most people would call maram, but it's not. If it breaks under load, and then from there you can now see it's just sand. Now because this has been consolidated over a long time, it has become hard. Now based on samples like this that you've recovered, you can now then go test them in the lab and then give recommendations on how it would perform when loaded in structures, or how it would perform when it's installed in dams. Such like soils, the sands, they're not good in dams because such soils are not good for dam construction because they have high seepage. They can allow a lot of water to go through, and then you'll have losses and even catastrophic failures. So this, like I had said before, is recovered by this bit. You see it almost fits, it's a perfect fit. And I guess that's all for today.
Welcome to Women in Construction, and we are still conversing with our engineer Arnold here, more on Geoworks. Engineer, thank you so much for being with us today.
Thank you for having me.
Okay, good. Engineer, you've talked much about this geowork. How is it necessary when you are doing construction, majorly to just a normal construction, residential, commercial?
Because, like I've said, you you don't know what is beneath you, so it's good to know what is there so that you can plan accordingly, so that you can prevent unnecessary collapses, things like that.
Of late, we've been seeing a lot of building collapsing, majorly in our country. I don't know, is there anything to do with the soil, probably?
Yeah, many times you can find that it was because the soil that was there was not appropriate for the building. You will find that someone has built a 5-story building here, and the next plot someone says he did it, I can do it too. What you don't understand is the soil changes quickly, abruptly, anytime. 3 meters away from here you'll find a huge boulder, and then out of that nothing. Beyond that nothing, maybe just bad soils, or what we call problematic soils. So it's as much as some of these failures, some of these collapses can be pinpointed to lack of geotechnical investigations or poor geotechnical investigations. It's usually recommended that you consult a professional whenever you're doing anything in the built environment.
Good. And probably through these recommendations, how do you go about it when you're giving a recommendation to maybe a contractor or a client?
Okay, so depending on the type of structure that you are putting up, and because now we are engineers, we cannot recommend extreme measures like removing everything and starting afresh. So we have many methods of improving the ground, and we have partnered with people like Sika that provide solutions for ground stabilization. This improves the properties of the soil that you want to use as your founding level, and it can enable you to counter the challenges that the poor soils are posing.
Engineer, now because we are talking much on women in construction, are you be able to incorporate women in your work, like doing the geoworks?
Evelyn, Akoth, and Juliet, they were not able to be with us here today. Engaged elsewhere in field works, so they are what holds the company together. Thank you.
Thank you so much, engineer.
Thank you.